Alright guys, so to start off with, on the insurance packet we started with linear functions. So let's go ahead and go through and remember how to graph and analyze the functions for behavior. And as I need to, I'll go back and review on a certain, or on specific topics, okay? Alright, so the first thing is y equals negative 9 halves x minus 4. And I want you to graph that first. So, if you remember in y equals mx plus b, in slope-intercept form, that's the slope, which is the rate of change, or the change in y over the change in x, and that is the y-intercept, b. That means where it crosses the y-axis, right? Okay, so slope, well, first always try and graph the y-intercept if you can. The y-intercept in this case is negative 4, which means I'm going to go ahead and go to the y-axis at negative 4 and plot a point. Then my slope is negative 9 halves. Negative 9 halves can be written, or is the same thing as saying, negative 9 over 2 or 9 over negative 2. Kind of depends on which one helps you better. In this case, you go down 9 and over 2. Remember, rise over run, so up and down on top and left and right on bottom. This means go up 9 and to the left 2 after that. And if you think about from a specific point, going down 9 and over 2 is the same thing as going up 9 and to the left 2. They put you on the same line. So in this case, since I can't go down 9 and over 2, I'm going to go up 9 and to the left 2. 1, 2, 3, 4, 5, 6, 7, 8, 9. Or I could just say 4 and then 5. And then over 2, and I want to connect. Make sure to draw the arrows at the end. If you just draw a segment, you haven't drawn a line. I'm going to end up with a different domain and range than I will. Okay, and so just as a reminder, domain is the all the x's for which this function is defined. So if you think about left and right, does it go all the way left and does it go all the way to the right? Well, as I keep going to the left, it's going to keep going down here. So yes, it goes all the way to the left, and it goes all the way to the right, because as I go left, it goes up. So domain is, you can say negative infinity to positive infinity. You could say negative infinity is less than or equal to x, which is less than or equal to positive infinity. Or you can just say all real numbers, which is a double bar r. And to write that, just write 1 bar, 2 bars, and then as if it was just 1 bar, draw an r. And there you go. Okay? Now, if domain is left and right, then range is up and down. So domain is x, range is y. Okay, so that means how far up and how far down does this function go? Well, this function is going to go all the way down to negative infinity. It's going to go all the way up to positive infinity, making my range the same as that one, all real numbers, or negative infinity to positive infinity. Any of these three answers are correct. It's just a matter of what you prefer writing, but you have to recognize them as all the same. Okay? Now, y-intercept is easy. We already know y-intercept. Y-intercept is the negative 4. Okay? X-intercept is where it crosses the x-axis, and it's easy to be like, oh, it's right there. It looks like it's negative 1. But you actually need to check that. So an x-intercept is when the x value equals 0, yeah? So when x equals 0, no, I'm just kidding. It's when y equals 0, the x value for which that's true, yeah? So y equals 0 means over here I'm going to take this equation, I'm going to set it equal to 0. Negative 9 halves x minus 4. And I want to solve for x. So we're going to add the 4 over. So 4 equals a negative 9 halves x. And you can do this in two different steps, or just in one. I want to get rid of, or I want to undo the multiplication of negative 9 halves. Or you could think of it as, I want to undo the multiplication of negative 9 and the division of 2. Either way, the opposite of dividing by 2 is to multiply by 2. So if I multiply both sides by 2, we get an 8 over here. And then the opposite of multiplying by negative 9 is to divide by negative 9. So basically what we're doing is we're multiplying by the reciprocal of negative 9 halves, which is negative 2 ninths. And the negative 9 simplify down to 1, 2 simplify down to 1, you're left with x equals 8 over negative 9, float the negative to the top, negative 8 ninths. So the x-intercept is actually negative 8 ninths. Now, if I were to write these as coordinate points, it would be x equals negative 8/9, y equals 0. And in this case, x equals 0, y equals negative 4. Okay. Slope, we already did. Slope is the m in the equation, and that was negative 9/2. And then end behavior. Okay, so let's take a moment and talk about end behavior. So I'm not sure everyone knows what that is. End behavior is where the function is going on the ends. So if I were to look at a graph like this, then I would say, and I'm going to do this in limit notation. If you haven't heard that before, that's okay. You're going to learn it, okay? The limit as x approaches positive infinity of y is, meaning here's what I want to know. Where is y going as x goes to infinity? As x goes to infinity, y is getting larger and larger. It's going to infinity. So the end behavior is, as you go to positive infinity, the function goes to positive infinity as well. Now, as we go to negative infinity, the limit as x approaches negative infinity of the function, if you don't put the y here, if you just write limit as x approaches negative infinity equals a number, then that's kind of like saying an empty square root equals 5. Doesn't make much sense because it's just an operation. You've got to have the limit of something. Okay? So the limit as you approach negative infinity. So as x goes to negative infinity, where's y going? Well, y is also going to negative infinity. So those are my end behaviors. So the end behavior on this one would be the limit. It's okay. The limit as x approaches negative infinity of y equals, and the limit as x approaches positive infinity of y equals. So on this one, as we go to negative infinity, as x goes to negative infinity, where's the function going? So as x goes to the left, the function's going up, so that would be positive infinity. As x goes to the right, where's the function going? Down, so that would be negative infinity. And there you go. Okay? Let's move on to number 2. Number 2 says x equals 3. Okay? Now, sometimes people have trouble remembering x equals 3. Is that what kind of line is that? Is it a horizontal? Is it a vertical? Well, remember, what it's saying is that no matter what, x is 3. So I go over to x equals 3, or 3 right here. And so when y equals 0, x is 3. When y equals 1, x is 3. When y equals 2, x is 3. It doesn't matter what y is, x is 3. So the only way that that makes sense is if you go through the x-axis at 3. Okay. If you think, oh, it's a horizontal line, then think if I went through 3 right here, the only time that I would have x and 3 being the same thing as right here, and that would be 1 point on the line. That doesn't really make sense. Okay. All right. Now, quick question: is this a function? And the answer is no. X equals 3 is a vertical line, and remember that doesn't pass the vertical line test because it is a vertical line. So, can you still graph it? Yes. Can you graph it on the calculator? Not in standard form. So, domain. Domain is left and right. So, remember that's the x values, and the only x value that this function exists for, or this non-function, this expression exists for, is 3. So my domain is just x equals 3, or you could do the curly bracket and just say that. Okay? Range is up and down the y's. So does it go all the way up and all the way down? And in fact it does. So the range is all real numbers, or negative infinity to positive infinity. X-intercept is where it crosses the x-axis, and this is pretty obvious. It crosses at x equals 3. So it crosses at the point 3, 0. And the y-intercept is where it crosses the y-axis, and since it doesn't, we just write none. The slope, well, remember slope is change in y over change in x. So if I were to think, if I were to take 2 points, remember it's y2 minus y1 over x2 minus x1. So if I were to take 2 points, like say this one and this one, okay. The second y value, if I do this one is the first point and this is the second point, then there would be negative 2 minus 2 over, so the two y values, this is negative 2 and this is positive 2, so y2 minus y1 over x2 minus x1. In each case, the 3's are 0. The x's are 3, which gives you 0 in the denominator, negative 4 in the numerator. I don't really care what the numerator is as long as it's not 0. If you divide by 0, it's undefined. So, in this case, the slope is undefined. You can say 0 divided by a number. 0 divided 7 ways is still 0. But you can't divide something 0 ways. So, that would be undefined. Okay, end behavior? Well, end behavior has to do with as you approach infinities. So as x approaches infinity, as x approaches negative infinity. And this doesn't do that. X doesn't approach a positive infinity, x doesn't approach negative infinity. So there is no end behavior. None. Okay. 3x minus 2y equals 2. Okay, so this is not in slope-intercept form. We could easily graph it this way. And I think I will show you that in a second. But I'll go ahead and talk to you about what you're most likely used to. And that is solving for y, getting y by itself. So if we do this, 3x minus 2y equals 2, we want to solve for y to get y by itself. We would subtract 3x over. I'm not going to write a whole lot of steps like minus 3x on both sides. Okay, at this point you should be able to do things like that in your head, know what you're doing, and write it down. So negative 2y equals, I'm going to go ahead and put it in the front, negative 3x plus 2. I want to get the y by itself, so I need to divide by the negative 2. So if I divide both sides by negative 2, it will be y equals, now negative 3 divided by negative 2 is just 3 over 2, because the negatives simplified down to positive. And then 2 divided by negative 2 is a negative 1. So I could graph it using that. I know that my y-intercept is negative 1, and my slope is 3/2, which means up 3 over 2, or down 3 to the left 2. I should say up 3 to the right 2. So 1, 2, 3, 1, 2, 1, 2, 3, 1, 2, and 1, 2, 3 down left 2, 1, 2, 3 down left 2. Okay. I do expect that if you can see the points, that you should probably go ahead and sketch them. On the first problem, there was only 2 points that I could graph. On the second one, it was just all vertical line. On this one, so I didn't just draw 2. I'd like you to go ahead and expand the graph. Now, if you don't, that's okay, but what I don't want you doing is plotting a point here, plotting a point there, and then just kind of, like, because some of you are not very good at lines, let's be honest, but if you draw something like this, and then you draw that and that, you're not exactly graphing it. What am I trying to say? You're not leading me to believe that you're going to end up in the right spot. So either plot all the points, or only plot the few points that you do, and be very careful, and then draw arrows right immediately after, okay? As it is, I'm going to do another one. And then connect. Okay? So, for domain, oh, I was going to show you another way. Okay. The other way to do this is to kind of, which doesn't really help you always as far as finding the exact points, but it is a way to graph. If I have 3x minus 2y, I can think about the two intercepts. So I know that you cross the y-axis when x equals 0, right? So if x were to equal 0, then I would get that, that's gone. Divide by negative 2, y equals a negative 1. So I could go ahead and graph y equals negative 1. And then I know that the x-intercept is when y equals 0, so I'd have 3x minus 2 times 0 equals 2. That's gone because it's 0. Divide by 3, and I get x equals 2/3. So I would graph right around there, which is kind of where we ended up. The problem with that is that it's kind of hard to go from there because it's a very small section. But if it works out nicely, like negative 4 and positive 6, then it's a pretty easy graph to make. Anyway, just a thought. Okay, so now I want to find domain and range. Now remember, domain is x and range is y. So x doesn't go all the way to the left and all the way to the right, because that's my x-axis, right? It goes all the way to the left and it goes all the way to the right, so my domain is all real numbers. Range is up and down. It goes all the way down, it goes all the way up, so range is also all real numbers. I need to find the x-intercept and the, well, we just did. X-intercept is when y equals 0. So if I go in here and I put y equals 0 and just basically cover it up, 3x equals 2, divide by 3, and you get 2/3. And y-intercept is just in this equation right here. And that is when you get 1, -1. So 0, -1. Or y-intercept is when x equals 0, cover it up, and then just divide by -2. Okay, slope. Slope we found when we solved for y. So the slope is 3/2, and in behavior. So again, the limits. So I've got the limit as x approaches -infinity of y, and the limit as x approaches +infinity of y. Okay? So I want to know, as I go to the left, where's the function going? As I go to the left, the function is going down. So that would be -infinity. As I go to +infinity, as x approaches +infinity, as x goes to the right, the function is going up. So that will be +infinity. Okay? One more just function to graph. Y plus 2 minus 1/2 x. So it seems easiest to go ahead and just solve for y. And you have a couple options. You can either subtract the y over and then get rid of the negative, or you can just move all of this to that side. So that was y plus 2, I believe. Yeah. So if I have y plus 2, then I'm going to subtract the 2 over. And I'm going to add the 1/2 x over. And then I'm just going to rewrite it, because it doesn't, having it right here, y on this side and that on that side, doesn't matter if I switch them. So I'm going to say y equals a positive 1/2 x minus 2. And there you go. Pretty sure it was a plus sign. Let me check. Yeah, it was. Okay. So y-intercept is -2. I could just go ahead and put that down here. And my slope is 1/2, so up 1 over 2. Up 1 over 2, up 1 over 2. Or down 1 to the left 2. Okay. Domain, does it go all the way left and all the way to the right? It does, so all real numbers. Range, does it go all the way up and all the way down? It does, so all real numbers. Will it always be that easy with linear? Pretty much. I mean, other than the vertical line and the horizontal line that you could get with y equals, it's going to be all real numbers. But we're going to move into different and higher level functions, in which case that will definitely change. Okay. So x-intercept is where it crosses the x-axis, and we already saw that it crossed at +4. The other option for finding that out, though, is y equals 0. Add the 2 over. The opposite of multiplying by 1/2 is to multiply by 2. So if I multiply both sides by 2, or dividing by 2, however you want to think of it, x equals 4. Okay, slope was 1/2, and the end behavior. So end behavior, as x goes to -infinity, and the limit as x goes to +infinity. Now we say limit because we're saying what the function is approaching. A limit is what a function is going towards. I mean, it kind of makes sense when you think about the definition of the word limit. But anyway, so as we go to -infinity, as x goes to -infinity, y is going to -infinity. So that is -infinity here. And as x goes to +infinity, y goes to +infinity. So +infinity. And there we go on that page. All right, the next two problems are kind of some application of word problems. So let's go ahead and work that out. Roger is running a marathon. He steadily runs 6 miles an hour for the entire marathon, 26.2 miles. Write a linear equation to represent his path and provide a graph representing how far he traveled, then determine the following. Okay, so let's see. When you're talking about 6 miles per hour, we're talking about a change in miles over a change in hours, which makes me think slope. Change in y over change in x, yeah? Which leads me to believe that y is in terms of miles, and x is in terms of hours. And so if I were to think about Roger running a marathon, let's hope that he started at the beginning of the marathon and didn't cheat and start somewhere else. He started at time 0. 0 miles away from the start line. So that would mean, I'm thinking that his starting point is right here at 0, 0, which is both the x and the y-intercept, so that would be 0, 0 for both. And then he had a rate of change of 6 miles per 1 hour. So that means he went forward 6 miles for every 1 hour on average. We're saying he steadily runs, so we'll just go with that. Although human nature is going to fluctuate a little bit. Okay, so we got another 6. So 12. I don't know why I'm trying to count it out. And then 18. So far he's gone 18 miles in 3 hours. And then 18, so 24. And remember that the marathon was only 26.2. So I'm going to kind of cap it out. So if that's 27, 26.2 is probably right around there. So I'm just going to kind of connect. And it probably went more like that. Okay. So here's what I know. I know that if I'm going to make, I guess I could put that there. X is hours. Y is miles. The equation would be y equals 6x, because it's 6 over 1, 6 miles per 1 hour, and 6 over 1 is the same thing as just saying 6, plus 0, and adding 0 doesn't need to be written, so we'll just put 6x. But it's got a restricted domain, so technically that would become part of the equation, so we need to figure that out. I already know the range. The range is the smallest number of miles he ran is 0, and we include that. And then the most he ran was 26.2. We're not including the fact that he probably ran for a couple steps after that or whatever. So 26.2 miles, right? So here's what I know. I need to find the actual domain. I need to find the specific length of time that he ran, because I know it's 4 and some, but I got to figure that out. So what I might do is I say, I know that he ran at 6 miles per hour for how many hours to get to 26.2 miles, because remember, y is miles, so if I let y equal 26.2, then I can solve. So x equals 26.2 divided by 6. If I type that in real quick. 26.2 divided by 6 is 4.36 repeating hours. I don't think you can. Yeah, I might as well just leave it like that. Okay, so as far as my domain goes, the least amount of domain is x, and x is hours, so 0 hours to 4.36 repeating hours. Now, what I'm going to go ahead and have you do in Algebra 2 is something that I need if you ever decide to take calculus, is that we go to 3 decimals. Now, 4.36 repeating is fine if you're talking about a person running, though you probably wouldn't say 6 repeating. You might say 4.367 and round it up. Or you could just say 4.366 and truncate it. So truncate means you just cut it off. You don't have to round, or you can round it. Either one is acceptable. So if you wanted to put 0 to 4.367, that would be fine. But technically, if you tell me y equals 6x, I'm going to go ahead and assume that it is going from there to there. So I would put a comma, 0 less than or equal to x less than or equal to 4.367. And that, you're defining the equation as having that constraint. It's this equation, but only for that amount of time. Okay? And slope with units, we already talked about that. It was 6 miles per 1 hour. Okay? And there you go. So in this case, do not draw arrows. You got to stop. Okay. You are selling candy bars, and you start with 50 and are selling them at a rate of 7 per hour. Okay. So we've got candy bars and we've got the rate at which you're selling them, 7 per hour. Write an equation to represent the situation and determine the following. Okay, so if you start with 50 and you're selling them, then it seems like the number of candy bars you have is decreasing. So I'm thinking it's saying 7 per hour and it's an understood 7 candy bars per hour, or 7 candy bars per 1 hour, so we can go ahead and say that that's our slope because that's the rate of change, with the exception of the fact that we are selling them, so we are decreasing 7 candy bars per 1 hour, so that would be a negative 7 over 1, or just negative 7. So I'm thinking y equals a negative 7 over 1x, or just negative 7x, and then plus my y-intercept, which is, remember, if this is hours, and this is candy bars, then we're talking about initial of each. At time 0, 0 hours, we have how many candy bars? And we have 50. I'm going to use that color. So we start up here at 50 candy bars. Okay? So that would be negative 7x plus 50. Now I would have you think, I mean, do we have a constraint here as well on domain? And think about the fact that domain is hours. We don't have the negative, so we definitely need to restrict it to 0. But then at some point, you run out of candy bars, which means hours is also going to run out here because you don't go down and we don't sell. We can't keep selling once we've lost them all. Okay? So, variables. Hours is candy bars. And let's talk for a second about the reality of the situation. So if you're selling 7 per hour, you could go down 7 and over 1, but with these numbers it doesn't, it's not exactly perfect. What we could do, if we want to find the x-intercept, is to just say that's when y equals 0. Right? So then we would say negative 50 equals a negative 7x, or add the 7x over and say 7x equals 50. Either way, you divide by 7 or negative 7, and you get x equals 57ths. And remember, 49 sevenths is 7. So we're looking at 7 plus a decimal. So 57ths is 7.143 if I round, 142 if I don't. So that would mean 7.143, forgot the one. And we'll go ahead and represent that because you could still keep selling all the way to the last bar, even if you don't, that last little bit, because after 7 hours you've sold 49 of them. So at 7 hours you're down to 1 candy bar. Yeah. And then you could sell that last candy bar, and it could take you 0.143 hours. So we'll put you right there. And since we're not going down an easy 7, because they're down by 5, so let's go ahead and just use a ruler or a straight edge and connect the two. And there's your equation. Okay? So your domain is only from 0 hours until 7.143, which I'll go ahead and put over here. And your range is only from, well, the number of candy bars, because range is y, right? And y is the number of candy bars you have, and you only have 50. So your range is just from 0 to 50. X-intercept, we said, is 7.143. And your y-intercept is 50. And then the slope is negative 7. Okay. Determine if the following functions are parallel, perpendicular, or neither. So first we need a little review on parallel, perpendicular, or neither. When two functions are parallel, they travel at the same slope. So that means m1 equals m2, the two slopes. If the functions are perpendicular, then they meet at a right angle. And the only way that is true is if the slope of one is the negative reciprocal of the other. So for an example, if one slope is 2, perpendicular to that is a negative 1/2. If one slope is a negative 2/3, perpendicular to that is a positive 3/2. So whatever fraction, remember 2 is 2 over 1. Whatever one slope is, the other has to be the exact opposite in terms of sign, and it's the reciprocal, not the same. And then neither just means neither one of these is true. Okay? So I already know the slope on this one. M1 is negative 2/5. So then I want to find the slope on this one. Remember that slope is the number in front of x, right? So I really kind of don't care about this number, the y-intercept. This is not the y-intercept, but it's going to be part of it. What I care about is what's in front of the x and what's in front of the y. If I were to move the 2x over, I would subtract it. And then just once that's gone, I want to solve for y, so I would divide by 5. And yes, I would be dividing the 30 by 5 as well, but all I'm really wanting to know is about the slope, and the slope would be a negative 2/5. Those are the exact same, so these are, I guess I could say A, parallel. Okay. On the next one. Again, we only need the number in front of x. So if I were to subtract the 3x over, that would be a negative 3x. And then I were to divide by the 2, that would be a negative 3/2 x. So M1, the slope of the first function, is negative 3 over 2. In this case, I would subtract the 2x over, because I want to solve for y, subtract the 2x over, and then divide by the 3 in front of the y. So M2 is a negative 2/3. Okay, this one's negative, this one's negative. This one's 3/2, that one's 2/3. They're not parallel, but they're not perpendicular either because they're both negative. So that would be C, neither. Okay, on the next one, y minus 3 equals 1/2 x. If I were to add the 3 over to get y by itself, it would still be that the slope is 1/2. So the slope of 1 is 1/2. And in this case, I need to solve for y. So if I add the 72 over and I subtract the 2x over, then y would be by itself. So that would just mean that this is a negative 2x plus 72. But that would mean my slope is a negative 2. Okay. This is positive, this is negative, so it's not parallel. It could be perpendicular, though. That's 1/2. And this is 2 over 1, technically. 2 is the same as 2 over 1. So I'm thinking that they are perpendicular. Now on 10, I already know the slope on this one. Although, I guess I should be looking. Okay. I just was thinking about something. On this one, if you solve for y, you get y equals negative 2/5 x, and then if you divide by 5, you get 6. So it's negative 2/5 x minus 3 and negative 2/5 x plus 6, which means they are parallel. One of them crosses at negative 3. So, and then the other one crosses at positive 6. They're not the same line. Just something to think about. So I think this might end up with a situation like that. So I've got y equals 3/4 x plus 5/4. So M1 equals 3/4. And in here I need to solve for y. So if I add the 6x over, 8y equals 6x plus 10, divide by 8, and I get 6/8, which is 3/4, and 10/8, which is 5/4. And that's what I was kind of thinking, because if you look at this, they're in fact the same line. Now, if you went and said 3/4, 3/4, therefore parallel, I mean, I would have to give it to you, because I only gave you 3 options: parallel, perpendicular, neither. But in fact, not only are they parallel, they're also they're just the same line. So technically, we'll say A, but then we'll also just say slash the same line. Okay. Solving equations. So these are linear equations, and it's just kind of a go back to algebra and see if you can remember how to do this. You've got 3 times the quantity x plus 4 minus 5x minus 22 equals 2x minus 15. what you want to do is, and as much of this as you can do in your head and do it correctly, I'm perfectly fine with that. I'm going to show steps, but as we go further throughout the year, the less steps I'll show, and the more you'll need to be able to do in your head. So I've got 3 times x plus 4, which would mean we would need to distribute. So we've got 3x plus 12 minus 5x minus 22 equals 2x minus 15. If you can do everything in your head from this point on, go ahead. If not, let's go ahead and combine like terms. So if I were to combine 3x and negative 5x, remember that these are on the same side. There's nothing that depresses me more is when someone does plus 5x and plus 5x right here. They are on the same side. There's no reason to try and add a different, or add the opposite to it, because we're not on opposite sides of the equation. So if I got 3x minus 5x, then that is a negative 2x. And then I've got 12 and negative 22. So 12 minus 22, or think about 22 minus 12, and that's 10, so it's negative 10, since the 22 is the negative one, equals 2x minus 15. We want to get all the x's on one side and all the y's on the other. You kind of have some choices here as far as steps. I prefer to keep my x positive if possible, but it really doesn't matter. So you could subtract this 2x over. I always deal with the variable first. Think about that. Or you could add the 2x, and that's what I'm going to do. So if I add the 2x over, I get 4x on the right-hand side, but you can switch that to the left. It doesn't really matter. So if I move this one over here, then I'm going to move that one over there by adding 15, which makes that 5. So x equals 4/5. 4.8. But I'd rather 4/5. Okay? On the next problem, we've got multiple distributions, it seems like we're going to have to do. So here I've got 4t minus 5, or 4 times t minus 5, which is 4t minus 20. If t's mess you up, if they look like plus signs, write an x or do a curly t, do what you need to do. Now here you got to be careful because you are distributing a negative 3, not just a 3, so that would be a negative 15t and a negative 6 equals, and here we're distributing a negative 6. So if you distribute a negative 6 to 1/2, remember, because I have people that do this, negative 6 times 1/2, and they multiply times top and by bottom. That's a negative 6 over a negative 12, which is 1/2. You did not end up multiplying that by anything, because you got back to 1/2. When you multiply by negative 6, you're actually multiplying by negative 6 over 1, and you multiply across top and bottom. It's negative 6 times 1, and then divided by 2. Or, the way I see it, if I see negative 6 times 1/2, I think 6 divided by 2 first is 3, and then I multiply negative 3 times 1. So that is actually a negative 3t. And then negative 6 times a negative 2/3 is a positive. And again, if I said negative 6 times a negative 2/3, I would say first that 6 divided by 3 is 2, and 2 times 2 is 4. Or you could say 6 times 2 is 12, and 12 divided by 3 is 4. Okay. Combine like terms on the same side. 4t minus 15t is a negative 11t. If you wanted to go ahead and add the 11t over there and get 8t, feel free. So negative 11t. And then negative 20 and negative 6 is a negative 26 equals a negative 3t plus 4. I want to combine like terms, so I'm going to add the 11t over and make that an 8t to keep it positive. If you want to move it over there, it's fine. And since I moved this over here, I'm going to move the constant over there. Subtract 4, and I get a negative 30. So if I divide by 8, then that's a negative 30 over 8 equals t. You need to simplify. They're both even. So negative 15/4 equals t. Okay. I'm okay with you giving me a decimal, but if I think that you give me a decimal just because you typed it in the calculator, then I'm not happy. You need to try and do things without the calculator, okay? You've got to have good number sense. All right. Solving a system by graphing. So when you're solving a system, you're trying to find when the functions meet, what their solution is that satisfies both of these in a single system. So what I'm going to do is I'm going to graph both functions, y1 and y2, and then we'll see when they meet. So I've got x minus 3 That means I've got a y-intercept of -3 and a slope of 1. So I'm going to go up 1 over 1, because 1 is the same thing as 1 over 1. Up 1 over 1, and left and down. So there's that one. And the other one is a 7x plus 2. So y2 is 7x plus 3. So y-intercept is +3. And then that means I need to go up 7 and over 1, if you will. Up 7 and over 1. I don't have space for that, so I'm going to go down 7 into the left one. 1, 2, 3, 4, 5, 6, 7 over 1. And I will go ahead and connect them because it is to solve by graphing. And the other point is to find the answer. I'm going to need to see some work, i.e. your graphs. So I know that they meet. These two are both satisfied at the point x first, -1, -4. Okay? On this one, I need to graph. So I'm going to go ahead and solve for y in both equations. So if I have -3 equals 2x plus 3y, then I'm going to subtract the 2x over and divide by the 3. So -2/3 x minus 3 divided by 3 is 1. And that equals y. I'm going to go ahead and put the y in the front. So y1 equals that one. So I'll go ahead and graph that. Y-intercept is -1, and the slope is -2/3. So down 2 over 3. Or up 2 and to the left 3. Okay. Now I need to solve for y in the other equation. So I've got -12 plus 7x equals a -3y. Seems like all I need to do is solve for y, or to solve for y is divide by -3. So -12 divided by -3 is a +4. 7 divided by -3 is a -7/3. And that equals y. So all I did was reorder it. I divided everything by -3. That divided by -3 is +4. That divided by -3 is -7/3. And that divided by -3 is just y, which goes right there. So y2 is, y-intercept is 4. And the slope is down 7 over 3. 1, 2, 3, 4. Okay, down 7 over 3. From +4, down 7 is -3, and then over 3 is a +3 there. Connect. And the point of intersection is 3, -3. So that is the solution to the system when these two equations are both satisfied. It's not always going to be very pretty, and in fact, sometimes what we would have to do is set these two functions equal to each other. And if we did that, we would still get the 3, -3. Okay. Solve using elimination. Okay, so elimination, if you remember, has to do with eliminating the variables. So when I look at these two systems, I notice that x has a -8 and a 2 in front of it, and y has a -1 and a 5 in front of it. And what you do is you make a choice on what you want to simplify, or what you want to eliminate first. If you want to eliminate the x's first, then you got to think, well, what can I multiply one of them by to make the other one go away? So if I look at this, -8x minus y equals a -1, and 2x plus 5y equals 5. I know that if I decide to do x's first, okay, I'm going to go ahead and write it on both, or twice, and do it both ways. Okay. Should you decide to eliminate the x's, then what I would say is you need one positive, one negative. We've already got a negative and a positive. You need them to be the same. Instead of dividing this by 4 to get down to 2, I'm going to multiply this by 4 to get to 8. So I've got -8x minus y equals a -1. And if I multiply by 4, I've got to distribute to everything. 8x plus 20y equals 20. And then what you do is you basically add the two equations. So negative 8x and positive 8x is gone. Negative y and 20y is a positive 19y. And negative 1 and 20 is 19, which makes y equal 1 if you divide by 19. If you know y equals 1, then you can choose which equation you want to do or you want to use, and then just go back and solve. So it doesn't really matter. I'm going to choose the bottom one. 2x plus 5 times 1 equals 5. 5 times 1 is 5. And if I subtract the 5 over, then I end up with 0. 2x equals 0. If I divide by 2, x is still 0. Okay? I would get the same thing here. If I plugged in 1 right there, it would be a negative 1. I would add 1 over. Negative 1 plus 1 is 0, and 0 divided by negative 8 is 0. Okay? So the answer is x equals 0, y equals 1, and that's a coordinate point. Because remember, if I had solved this by graphing, we would have been looking at a coordinate point. So your answer needs to be in coordinate point form. X, and then y. And there you go. Okay. If I had chosen to manipulate the y's instead of the x's, I've already got one positive, one negative. I've got a negative 1 and a positive 5. And so if I were to multiply this top equation by 5, negative 40x minus 5y equals a negative 5. And the bottom equation I left alone. And I added the 2. Then I would get negative 38x. Those two would simplify out, and that would be 0. And 0 divided by anything is, other than 0, is 0. Okay? If I got x equals 0, then all I'd have to do is say, well, if x equals 0, then that's gone. I've got 5y equals 5 divided by 5, and y equals 1. Okay? So on this one over here, there's a couple things to think about with this problem. I'm going to go ahead and treat it as if you didn't do any kind of preliminary steps before you start solving. Okay? So if I had 6x plus 8y equals 6, and I had negative 9x minus 12y equals negative 9. And I said, I want to cancel out the x's. Well, what do they both go into? They both go into 18. 6 goes into it 3 times, and 9 goes into it twice. So I would maybe multiply the top equation by 3 and the bottom equation by 2. I don't need to make any of those negative because I've already got a negative here and a positive there. So I would have 18x plus 24y equals 18. And down here I would have negative 18x minus 24y equals a negative 18. And what I would end up with is 0, 0, and 0. Which is not like an answer. It's not like the answer is when x equals this or when y equals that. The answer is that 0 equals 0, which is just a true statement. When you get a true statement, that means these two always equal each other. They equal each other all the way from x equals negative infinity to positive infinity. And here's why. If you look at this equation, 6, 8, and 6, they both are all three numbers divide by two numbers. Divide by 2. So if I divide this by 2, I get 3x. If I divide that by 2, I get 4y. If I divide that by 2, I get 3. These all divide by 3. And in fact, I could go ahead and divide by a negative 3, and I would end up with 3x plus 4y equals 3. They are the exact same equation. So it makes sense that if we're trying to solve for when these two functions equal each other, these equal each other one time here, one time there, only one time. These equal each other the whole time, so the answer to the system is all real numbers. They always equal each other. Okay? If you notice that they simplify beforehand, then go ahead and simplify. Even if it doesn't end up with an answer like that, if I saw a 6, 8, and a 6, I would immediately divide by 2 so I didn't have to deal with bigger numbers. Okay, substitution. So substitution is, you should be familiar with it, but what you do is you take a variable, solve for it, and then substitute it into the other equation. So you have some choices. You want to solve for the ones that's easiest to solve for. If I solve for x, all I have to do is subtract 3y. Easy. If I want to solve for y, I've got to subtract x and then divide by 3. Not my favorite. If I want to solve for x, I've got to add y and divide by negative, not a big deal. If I want to solve for y, I've got to add the x and divide by a negative, not a big deal as well. But the easiest one to me, it seems like, is to solve for that x in that equation. So I get the x equals a negative 3y plus 21, or 21 minus 3y. It doesn't really matter. Okay? So it's called substitution because at this point what I do is I take the second equation, and in place of x, like it says right there, I substitute in what x equals in the other equation for x, and then we solve. So we'll simplify and solve. You have to remember that this negative applies to that x, and this x is a quantity, so that means I have to distribute the negative. So that becomes a positive 3y, a negative 21, and minus y equals a negative 9. 3y minus y is 2y. Add the 21 over. 21 minus 9 is 12. So I've got a positive 21 or a negative 9 plus 21, either way. And divide by 2, and y equals 6. So once I know y, then I can then substitute it into the original expression that I got for just x, and I get x equals negative 3 times 6, which is negative 18, plus 21. And that is positive 3. So I get x equals 3, y equals 6. Remember, it has to be coordinate point form. Okay. On number 18. I want to solve by substitution, so I only did this with the x. You could have done this with any of them. It doesn't really matter. It would have worked either way. If you solve for x here, you got to plug it back into this x right there. So it's kind of up to you. Solving for x and y actually wouldn't be too bad here because this is 0. But if you don't think of that right away, then I would gravitate towards one of these two. And in fact, this one looks easiest because all I got to do is add y. X equals y plus 4. But in fact, if you were to solve for x here, all you got to do is add 3y and divide by 3. You get x equals y. But anyway, if you see that, then that's a different. Makes it pretty easy. So if x equals y plus 4, and if I were to take this and plug that in for x into that equation, then I have 3 times y plus 4 minus 3y equals 0. Distribute, you get 3y plus 12 minus 3y equals 0. 3y minus 3y goes away, and you get 12 equals 0. If you get 12 equals 0, that's not a true statement. And if true statements means they always equal each other, then a false statement means there is no solution. I tend to write the sum, or a lot of people like to do that. Doesn't really matter. If you had solved for, like, say y, let's say x right here, it doesn't really matter. If you said 3x equals, you add 3y, and you get x equals y, right? If you had done that, then you could have said replace x with y in the second equation. Y minus y is 0 equals 4. 0 does not equal 4. Either way, you're going to get that this is a false statement. And the reason that this is a false statement, the reason that these two functions never equal each other is because they are, in fact, parallel with different y-intercepts. So if you think about this, 3x minus 3y, I probably shouldn't do it up there. Okay. If I were to say 3x minus 3y equals 0 and I wanted to solve for y, I would either subtract 3x and divide by negative 3 or just add the 3y and divide by 3. Doesn't really matter. I'm going to go ahead and do that. Negative 3y equals a negative 3x. Divide by a negative 3, y equals x. Yeah? So my slope is 1 and my y-intercept is 0. So if I were to sketch this, y-intercept is 0, slope is 1. So it would look something like that. Now on this one, x minus y equals 4. If I have x minus y equals 4, I would subtract the x over. Negative y equals a negative x plus 4. Divide by a negative, and I've got positive x minus 4. That means my slope is 1, and my y-intercept is negative 4. So 1, 2, 3, 4. But slope is the same as that one. So if they're parallel and have different y-intercepts, then they're never going to meet, which makes sense. but the system that has no solution. Okay? All right. So these are systems in word form, so basically you've got to come up with the equation to represent the system and then solve it using whatever method you want to. So, I'll just pick a method and go with it. Mr. Conley sold water bottles in 2 sizes, large, $2.50 each, and regular, $1 each. He sold 113 bottles altogether and collected $221. How many bottles of each type did he sell? Okay, so here's what I could say. I could let large equal X and regular equal Y, and then think about the fact that if I let X equal the number of large bottles and Y equal the number of regular sized bottles, then it makes sense to find the equation. It says how many bottles, okay? It makes sense to find the solution. The solution is going to give me a number, okay? So if I were to think about this, he sold 113 bottles. So that means the number of large bottles plus the number of regular bottles is 113. Well, I don't know what the number of large bottles is, but I know I represented it with an X. So I could say X plus Y, the number of regular bottles, has to add up to 113. Now, if you think about price, if I sold 20 large water bottles and I wanted to know how much money I had, well, then I would multiply 20 times 250. So I would say 250 times the number of large bottles plus $1 times the number of regular bottles adds up to the total amount of money that we drew in, and that's $221. Yeah? Now, if I'm trying to solve using elimination, there's an easy way to do this. I can multiply the top by negative 250 and cancel all the x's. Or I can just look at the y's and notice that they're both 1. So if I were just to make that negative, then the y's would cancel out. So I've got 250x, 2.5x, I should say. If I multiply this by negative, then I've got negative x, I've got negative y, and I've got negative 113. So those simplify out. 2.5 minus 1 is 1.5, so 1.5x equals 221 minus 113, so that's 108. You can do this in the calculator, but 1.5 is 3/2 x equals 108. So if I'm trying to solve for x, I would multiply by the reciprocal of 3/2, and that's 2/3. Like I said, you can do this in the calculator, but I prefer you to try and do it by hand. So if I multiply by 2/3, I'll simplify out. 108 divided by 3, 3 goes into 10. 3 times with 1 left over, 18, so 36. And 36 times 2 is 72. So x equals 72. And remember, x is the number of large bottles. So 72 large. And then I know that x plus y has to equal 113, so if 72 plus what? Equals 113, so subtract 72. So that leaves me with, let's see, 13, oh, expensive. We'll just do it. It's 41, yeah, 41. And there we go. Although I do suggest that you check it. So 72 times 2.5 plus 41 times 1, or just 41. It's 221, and that's how much money. Okay, good. And remember, don't say like x equals this, y equals that. Okay, this is a situation. I need a real answer. If someone asked you that question and you were like x equals 72, they wouldn't know what you're talking about. Okay. Mrs. Jacob. I'm going to pretend like that was Mrs. Jacobs. Is selling tickets to a play. On the first day of ticket sales, the school sold 2 senior citizen tickets. So I've got senior citizen tickets and I've got child tickets. I could let that be X and I've got Y. Yeah? So they sold 2 senior citizen tickets and 1 child ticket for a total of $26, and then the school took in $15 on the second day by selling 1 of each. So what I can say is if X represents the number of senior citizen tickets and I don't know, I already know the number. It's gonna have to represent the price. That's what we're trying to find, the price. Find the price. Okay, so this is gonna be senior citizen tickets cost X dollars and children's cost Y dollars. So if I sold 2 at X dollars a piece for the first day, plus 1 on the second day, and brought in $26. And on the next day, 1 of each for 15, then what would each cost? You could do substitution if you want. X equals subtract the Y over, Y equals subtract the X over, plug it into the other. I'm going to go ahead and do elimination just because it's easy. If I multiply this by negative, and I'm going to choose, now these are both 1, but I'm going to go ahead and multiply this by negatives because it makes it 15 negative. Doesn't really matter though. So I've got 2x plus 1y equals 26, and then I've got a negative x, a negative y, and a negative 15. And I'm left with x, and 26 minus 15 is 11. Yes. Okay. So x is the price of a senior citizen ticket. So I would say senior citizen ticket is $11. And then here's what I know. I know that the price of one plus the price of the other has to add up to 15, so if this is 11, then this has to be 4. Not very nice to the senior citizens, but thankfully it's made up. Okay, simplify the following expressions. So on number 21, I want to simplify, and I have to remember the properties of exponents right quick. You can only add like powers with like powers. So there's really not much for me to do. I've got a power of 4, a power of 1, a power of 2, a power of 3, except for right here, where I've got a quantity being multiplied by negative 3x, so I need to distribute. So you just got to remember that 3x times x is 3x squared. 3x plus x is 4x, because you're adding 3x's plus another x. So this is actually a negative 3x squared, and a negative 3x times 2x squared is a negative 3 times positive 2, which is negative 6. X times x squared is x cubed. Okay? So then I just got to add like terms, and I'm going to put it in standard form, meaning highest power first. The highest power of c is power 4, so 5x to the 4th. The next highest power of c is 3, but I've got a negative 6 and a negative 7, so that's a negative 13x cubed. Next highest power is 2, I've got a negative 4 and a negative 3, that's a negative 7x squared. And then 1, so plus 2x. No constants, and there we go. Okay, on the next one, we've got multiple variables m and j, so we need to go ahead and distribute when we need to and simplify. So right here, if I multiply 6m squared times 4mj, then I've got 6 times 4, which is 24. M squared times m is m cubed, and then 1j, plus 6 times 3 is 18. I've got m squared times m, which is m cubed, and then j squared. And then here I've got j cubed, negative j cubed, times 2mj squared. So I've got a negative times 2, which is a negative 2, m, and then, well, there should be j, and this j's before the other in the alphabet. Okay. So I've got m and then j to the 5th. Just remember that, like, j cubed times j, no, that's not a j. I spelled j. J cubed times j squared is j times, I keep trying to do y, j times j times j. J cubed, j squared adds up to j to the 5th. So you just add the powers. And then a negative j cubed times a negative 5m to the 4th j is a positive 5 m to the 4th j to the 4th. M to the 4th and j cubed times j. So then we need to combine like terms. So I'm going to go by m's on high power, I think. Yeah, I think that's what I'm going to do. I see m to the fourth here, m cubed, m cubed, m cubed. So that's the first term of m to the fourth, j to the fourth, m cubed. So I've got m cubed j squared, m cubed j squared. So these two have the same variables. The same variables of the same power. So m cubed j squared. I've got 3 of them plus 18 of them. That's 21. M cubed j squared. And then I only have one more m cubed. So plus 24 m cubed j. And then I've got an mj to the fifth and an mj to the fifth. I've got negative 4 and then negative 2 of them. That's negative 6 mj to the fifth. And there you go. Okay. On 23 and 24, what you're supposed to do is recognize that you have to distribute. Use the distributive property. So, I'm going to go ahead and do that. First I'm going to distribute the 2x to both of those. So 2x times a negative 1/2 and 2x times a positive 5. You should get to the point throughout the year where you just do these in your head and you don't have to write anything down. So you should be able to just jump straight to the answer. We'll get there. 2 times a negative 1/2, and some of you might already be there. 2 times, well, first a negative times positive is a negative. 2 times a half is the same thing as 2 times 1 divided by 2, or 2 divided by 2 times 1. Either way, 2 times a half is just 1. So I've got positive times a negative, 2 times a half is 1, x times x is x squared. Okay? 2x times a negative 1/2 x. Negative, 2's cancel out, and then x squared. 2x times a positive 5 is a positive 10x. A negative times a negative is a positive. 4 times a half, or 4 halves, is 2. Or 4 divided by 2 times 1. So that's 2x. And then negative 4 times positive 5 is negative 20. So final answer, negative x squared plus 12x minus 20. Okay. On the next one, we need to distribute as well, but we got 2 different variables, that's okay. I've got 5x times negative 2x, it's a negative 10x squared. I've got 5x times 7y, that's a positive 35xy. I've got a negative 3y times a negative 2x, that makes a positive 6xy, or yx, but I'll go ahead and do the same order. And negative 3y times a positive 7y is a negative 21y squared. So we combine like terms, negative 10x squared, 35 plus 6 is 41, and then minus 21y squared. Okay? Sorry, I couldn't do that. Okay. On 25 through 30, we're solving literal equations. So you've got to solve for the variable that is asked for at the end of the equation, which means you're going to have to undo operations. In fact, I think I'm going to go ahead and do these and then make another video so it's not so long. Okay. A equals WH, and I'm going to solve for W. Well, right now we're multiplying by H. The opposite of multiplication is division, so divide by H, and I'm good. A divided by H equals W. Okay. On 26, I want to solve for R. Solve for R. We are multiplying by pi and then raising it to a power of 2. You cannot get rid of the power of 2. You cannot undo that power until you undo all the things around it. Okay? Order of operations says I have to undo this multiplication before I can undo that exponent. So divide by pi. So A divided by pi equals R squared. I want to solve for R. And you learned from Pythagorean theorem a long time ago that the opposite of the square is the square root. So if I want to undo R squared, or if I just get R by itself, then I take the square root of both sides. And we'll talk more about square roots later. But R is the square root of A over pi. Technically, it should be plus or minus. But we can talk more about that later. Okay. On 27, I want to solve for R here. I'm multiplying by a 4/3 pi, and then I'm raising r to the third power. When dealing with this, you can do things you can do them separately, you can do it all one time. The easiest way to do this is not to divide by 4/3. Do not do that, okay? That's not good math. I mean, it is, but then only if you know how to rewrite that, and is what it should be expressed as, okay? So if we've got 4/3 pi r cubed, you could think of it as volume equals 4 pi r cubed divided by 3, because technically multiplying all of this by 4/3 is multiplying it by 4 and dividing by 3. The opposite of dividing by 3 is to multiply by 3. So I would multiply both sides by 3. And then you're multiplying r cubed times 4 pi. So you'd want to then divide by. So 3v equals 4 pi r cubed. You would want to get r by itself. So you would have to divide by 4 pi. And then 3v over 4 pi equals r cubed. And if the square root is the opposite of the square, then the cubed root is the opposite of the cube. So we would take the cubed root of both sides. Okay? So r equals the cubed root of 3v over 4 pi. Okay. On 28, I want to solve for p sub 1. Just to go back to the last problem, there's not a plus and minus because it's an odd root. And again, we'll talk more about that later, but there is not a plus or minus. Okay, so on 28, I want to solve for p sub 1. P sub 1 is inside this expression right here. A couple different ways to attack this. You could, I'll do it both ways. And they'll be the same. So let me write it down twice. Okay. One way would be you want to get p sub 1 alone, so you undo the multiplication by 0.05, so divide. P divided by 0.05 equals p sub 2 minus p sub 1. You want to solve for p sub 1, so you want to get rid of the p sub 2. P sub 2 is being, p sub 2 is in front of that, so I would subtract it over, or you could add p sub 1 and subtract this. It's kind of up to you whether or not you can see that. So if I subtract p sub 2, I'm only doing that so you can see how that's going to happen. So I've got p divided by 0.05 minus p sub 2 equals a negative p sub 1. I want p sub 1 by itself, which means I would need to undo that negative. And dividing by a negative or multiplying by negatives is just in effect changes the sign. So that would be a plus, and a negative. So you could say p sub 1 equals p sub 2 minus p divided by 0.05. Okay? And that's an acceptable answer. This option, what I'm going to show you here, makes it to where you don't have two different expressions. So if you distribute 0.05, you've got p equals 0.05 p sub 2 minus 0.05 p sub 1. And if you then subtract, actually, you know, I'm going to go ahead and do what I said earlier. I'm going to add this over here and subtract this over there to make this positive. So 0.05 p sub 1 equals 0.05 p sub 2 minus p. And then I want to solve for p sub 2, so I divide by 0.05. I want to solve for p sub 1. So divide both sides. P sub 1 equals 0.05 p sub 2 minus p over 0.05. If you were to divide each of these by 0.05, you would end up with p sub 2 minus p over 0.05, because these two would simplify out. But because it doesn't simplify out there, don't just like cancel them out. You can't do that. That's called bad. Okay. I want to solve for Celsius here. You can do the same thing that I just said, or you can, you can do it either way. You can get rid of 9/5 first. The opposite of 9/5 is 5/9. Or think of it as multiplying by 9, dividing by 5. The opposite is to multiply by 5 and divide by 9. So 5/9. So I've got 5/9 F equals C minus 32. I want to solve for C, so we add 32. 5/9 Fahrenheit plus 32 equals Celsius. And there you go. And then rate equals distance divided by time. If I'm trying to solve for time, okay, what you cannot do is just multiply both sides by distance, d. It doesn't work that way. It would just be d squared in the numerator, would not have gone away. You could divide by d, but t is still in the denominator. You've got to recognize where it is and not just magically move it, okay? Because t is in the denominator, and it's what I need to solve for, I don't want it in the denominator, so I'm going to multiply both sides by t. It gets it out of the denominator. So I've got tr equals d. I want to solve for t, so divide by r. Distance divided by rate. And if you notice, these two just end up switching. Okay, like I said, that's going to be the video for 1 through 30, and then I'll make another video for the other part.